Hey folks, it's Kary Oberbrunner with another episode of Blockchain Life. I have with me a super intelligent person. Her name is Medha Parlikar. Did I get that correct?
Yes, you did. Thank you.
Awesome, awesome. Well, listen, tell us a little bit about you're a CTO, Casper Labs. Give us a little bit of the background for you.
Yeah, so Casper Labs was founded in October of 2018. And prior to that, I've worked in cloud software, as a leader in engineering,
Mm,
helping teams ship really high quality product for customers in the large, software as a service or cloud, space.
awesome. Okay. And a lot of my audience is just new to the Web3 space. And in fact, that's kind of my calling, if you will. It's to how to onboard people who might be not techie or, my whole world is publishing. And give us a little bit of the terms and the jargon, like what do you do exactly? Break it down for your common Joe out there.
Okay, yeah. So when you think of Web3, it's the term that's been coined for this class of technology that uses blockchain protocols.
Mm,
And when you talk to most people about blockchain, they just know Bitcoin, right? And they think of
mm,
cryptocurrency. But in fact, blockchain is a lot more than just cryptocurrency. I like to think of cryptocurrency as the first broad use case of blockchain, right?
mm.
So you can have blockchain without crypto, but you can't have crypto without blockchain, right?
Ooh.
Yes. And so blockchain technology has actually been around for a long time. And when Satoshi Nakamoto created Bitcoin, he didn't really invent blockchain technology. What he invented was the crypto economic model that backs Bitcoin. That's really the innovation that he brought to bear.
Perfect.
And so I like to think of blockchain technology as a trust layer.
Mm,
So any information that goes through a public decentralized blockchain protocol can be trusted. And that's why you can have crypto, you can have what we call value accretion or value building of value on the blockchain, because now you can trust it to protect that value. It's secure.
okay.
Right. So that's what I see blockchain as. And when you think of Web3, it's a class of applications that use this trust layer known as blockchain. That's what
Mhm.
Web3 is.
Perfect. Perfect. So for the person who is learning all this for the first time, blockchain, of course, is a distributed ledger. It's immutable. It's unchanging. It's, I've heard people say, why can I trust a computer? And I try to tell them, well, listen, you'd have to hack 51% of computers, and this is what I'm told, correct me if I'm wrong, but if you were truly able to hack 51% of the computers, okay, fine, then you could change the blocks in the blockchain, but even then, it would be quickly discovered. Is this accurate?
It is accurate, right? That's when I talk about blockchain. I'm very specific about saying public permissionless blockchain, right? Which is what you see in Bitcoin and Ethereum and not all the layer ones out there, but many of the layer ones out there, right? Casper happens to be a similar layer one, where you have participants that don't know each other. And they could run different versions of the protocol. The software is all open source, right? So it's subject to scrutiny. And, because you're creating value on these systems, there's a lot of incentive for people to attack them, right? So the longer a protocol is out there in the wild, the harder and more trusted it becomes because it's been subject to these kinds of attacks.
Yeah.
And one attack is a malicious person trying to get control of the network. It's referred to as a 51% attack, where if you control a majority, right, you can push through what you want to push through. And so, in the simplest way of looking at it, it's because you have people that are just random, right, all running the same protocol that are trying to unnecessarily attack this protocol to steal from it, is where you get the security guarantees about putting value on the blockchain and then being able to transact with somebody that you don't trust or don't know. And that's really the power of a public permissionless protocol.
Yes. And certain companies, Morgan Stanley, Chase, others, they could essentially create their own internal blockchain, which is really just it's essentially just a network, but it's not the same as a permissionless, trustless blockchain.
That's
It
right.
it's more just a semantics that hey, they're just saying they have a blockchain, but really it's all internal.
That's right.
Yeah.
That's exactly right. That's
Okay.
exactly right. Yeah. And that's the really big fundamental difference between private permissioned blockchains and public permissionless blockchain. It's
Yeah.
not possible to just arbitrarily update what all the participants in the network have agreed upon in terms of the version of the software that they're running. But if I control the entire network, I can change the software to do whatever I want it to do,
Yep.
right?
Yep.
And so that's really the fundamental difference, right? When we
Mhm.
push an update out or we request the community to accept an update of the Casper protocol, we have to get 2/3 of the network to agree before anything goes out on the Casper network.
Wow.
And so we just, we sit around and we wait to see what the community is going to come back and tell us whether they've accepted our update or not. It's always a pins and needles kind of thing because we just don't know who's running the nodes and who controls, the network at it. Yeah, in terms of the collective, right? What the collective consensus is socially.
And this is where blockchain and Web3 fascinate me from a philosophical standpoint and a humanitarian standpoint, meaning it's truly a decentralized world that we're now moving into. In other words, we used to have fiat currencies where governments, I mean, we still do, but they can print as much money as they want. There's
Hmm.
no accountability.
Hmm.
You don't have to attach value creation to it. And it essentially, uh, you know, I would say, debases everyone. There's books out there that talk about how it's essentially theft. And,
Hmm.
I mean,
Yeah,
now,
universal basic income for the rich, right? Because if you have hard assets, that the inflation gets baked, it gets priced in, right? So you see the
mm,
prices of gold and silver and crude and real estate and artwork, all of these assets, prices are going through the roof, right? But if you operate in cash, right? And if you operate like a huge chunk, right, of the non-wealthy operate on cash, they've lost about 40 to 50% of their value just in the last year, right?
that's
Because of
crazy.
the Fed increases balance sheet by $10 trillion. And
Yeah,
it's silent. It's so silent and it's so easy for them to just, add something in their ledger and boom, they've created, they've basically taken a lot of prosperity from the average,
yeah.
individual. And so it's very, very detrimental. And I think a lot of people are not aware of the impacts. And yeah, I'm very hopeful. I'm optimistic that this technology will provide an alternative form of value where people can actually hold on to what they, the wealth that they create. And one of the things that's really interesting and that you see in the crypto community is people are very particular about how they spend their crypto. There's a very much a what we call hodling or holding culture within crypto because we believe that the future value is going to hold on to its value. So there's very little incentive to spend.
Yeah.
And I think we've really, as a society, stepped away from this notion of building for tomorrow and saving our money because there's no incentive. We
Mm,
believe that, we know instinctively that the money is being devalued day over day,
yes.
right? And so our spending habits, as consumer economy, reflects that, right?
It's like Michael Saylor talks about this ice cube melting, where the current cash essentially I saw Bitcoin conference posters that were already coming out that said, I believe it was in the last 22 months, 80% of dollars have been printed or something crazy like that, something
Yeah.
like that. And it's true. It's basically saying like the dollars that you have today will be much less value 6 months from now.
Hmm. Yep.
And I didn't understand that, until I read and studied a lot of this. So I'm so glad you're talking about it. Now let's talk about proof of stake, proof of work, because you are breaking this down so good. We've had guests on that have their own specialties, metaverse architects and all this, but you're really breaking it down for the common person, which is my audience is saying, please teach us. So talk to us about why people are incentivized to solve these complex math problems and the mining concept. Can you break that down a little bit for us?
Yeah, absolutely. So, there's this function in mathematics known as a hashing function. And a hashing function is a function that takes any input and generates this thing called a hash out of it. And there's a bunch of different algorithms that do this. And so what they wanted to do in proof of work specifically, those consensus, and a consensus protocol is how you get a bunch of computers to agree when they don't trust each other, right?
Yes.
So it is it's basically, it forms the foundation of blockchain technology. And it's not new. It solves a theoretical computer science math problem. That's the Byzantine generals problem. And so we'll just leave it at that. But just know that this is what a consensus protocol is. And it's how the computers agree in the network on a set of transactions when they don't trust each other. And so the proof of work is a form of consensus. Proof of stake is another form of consensus. And in proof of work, there will be a parameter that in order to propose a block, you have to propose a hash that is verifiable to the other members of the network to prove that you've actually gone through and solved this computational puzzle. And it's a very simple thing. It's the puzzle itself is simple, but what it is you have to go through a lot of permutations, right? So you try, oh, this didn't work, this didn't work, this didn't work. It's literally it's a numbers game where you just keep firing the numbers. That's why it's called work, because you have to keep doing that work until you get one that matches. And the speed at which you can go through these permutations is directly tied to the CPU or the size of the processor you have or the processing power you have. And the hashing function, because it's very CPU intensive, becomes very expensive in terms of energy consumption, right? And in the consensus protocol, it's a race. It's a race to see who's going to get to propose the next block, who's going to solve the next puzzle that will be accepted. And so why do they do it? Well, the reason they do that is because with every new block, new token is minted or created in the same way that the Fed creates money. Very similar to that. It's minted, quote unquote, out of thin air. And the winner who proposes the block gets that new token added to their account, right? Just like, we have account numbers in our bank. You have something similar on Bitcoin, Ethereum, and all these blockchains. You have account numbers.
And is this represented in the gas fee?
It's not. So in Bitcoin, it's not represented in the gas fee. Gas fees are separate. So there's two things, right? There's the fees that I pay to send a transaction, just like when you pay a fee to send a wire or an ATM fee, similar, right? So to use the network, you pay a fee. That is very similar to what we're used to today. And it's typically called gas fees or transaction fees. So if I process 100 transactions in my block, I get two things. I get the fees associated with processing those transactions, but then the protocol actually rewards me for participating and doing the work by giving me some net new token. It could be Ethereum or it could be Bitcoin.
Is this mining?
This is the idea of mining. The act of mining is solving the puzzle. The reward for mining, because when you mine, you want to get some gold, you want to get some diamonds, or you want to get some Bitcoin, right? So the reward you get for doing the work is the Bitcoin protocol will pay you 6.25 Bitcoin right now, and it will pay you all the transactions that are included in the block in terms of those transaction fees, right? And so when we talk about the Bitcoin halving, we talk about this block reward going from, it was 13, it was started off at 50, then it went to 25, then it went to 12.5, and now it's 6.25. That's called the Bitcoin halving, where algorithmically the amount of Bitcoin that gets added with each block reduces by half, right? And it will continue on till about 2040. this halving process where the amount of Bitcoin rewarded goes down and down. So, and this is a specific, like these are specific details about the consensus algorithm or the crypto economic model for
Yes.
each blockchain.
Yes. And in 2040-ish is when we'll hit 21 million Bitcoin.
That's correct. So at the point that there's no more net new minting, there's no more block rewards in Bitcoin, that's when we'll hit the 21 million number. It will stop minting new Bitcoin, and then at that point, miners will only receive transaction fees, right? So the reward will be just the transaction fees at that point in time.
But see, that's interesting. I'm glad you said that, because in my mind, I know enough from my studies, but I didn't know how it would continue. But you're saying it will continue because even though new Bitcoins aren't mined, they'll still get gas fees or
transaction fees. That's right.
transaction fees.
Yeah.
Okay. And when they still get transaction fees, will they perpetually increase forever, do you think, because no more coins are being mined, or it's tough?
Yeah, so it's a really great question. Not sure what's going to happen in 2040, right? So the Bitcoin community could choose to make a change if they all agree that they need to continue minting Bitcoin if 21 million isn't enough. But that would actually go through community consensus, and it would have to be accepted by all the miners, right? And so this is where it's more decentralized, right? This is where you talk about decentralization.
Yes.
One person cannot arbitrarily make that decision. Somebody
Right.
could propose it, but then every single 51% of the miners have to accept it and install it, right, on their local Bitcoin nodes. And so that's where things start getting really interesting in terms of the governance, of the protocol and how changes actually get made.
And governance in Web3, other than Bitcoin, is represented in what's called DAOs, decentralized autonomous organizations. Is that true?
It's one, not necessarily. It's one form of governance, but I think if you wanted to talk about governance in an overarching, like as a single unifying definition, governance really is the set of processes by which protocols propose, implement, and accept updates, right?
Gotcha.
That's really, and I maintain that all software is governed, right? It's just centrally governed. But if you go into any software organization, there's a very rigid process by which changes go from product into engineering. Then they have to go through UAT. Then they have to go through, network operations testing, and right. So there's this pipeline, right? So it's similar. The challenge is it's decentralized, so it's a lot slower, right?
Yep.
Versus when it's happening in central organizations. But I think the underlying, like the fundamentals underneath them, are very similar, right? Yep. So somebody makes a proposal, it has to get reviewed. Is it beneficial? Everybody has to be heard. Then it needs to get implemented. Is it match the spirit of the proposal and implementation? Has to go through testing and then approve. So all that happens, right?
Yeah.
In terms of governance. So if you want to talk about proof of stake, we can kind of like switch gears to proof of stake, and I can go through that. So when you think about, mining a Bitcoin or mining some Ethereum, you have to invest a lot of money in your physical hardware, right? So, and then you have to invest ongoing, money in terms of energy, right? So you have to spend energy. So proof of stake networks and majority of the new protocols, I would say over 90% of the new layer 1 protocols, maybe even 95%, are all proof of stake layer 1 blockchains. And what they do is they say, well, rather than asking you to put out energy consumption and all of this heavy duty hardware, we're going to ask you to put up some stake. And you can think of stake very similar as bond, right? So it is a capital investment, but the capital investment comes in the form of tokens in the native platform, right? So whatever the protocol is, it will have its own token, probably for gas fees, but also for stake to actually secure the network. So if I want to participate as a validator or as a token holder, I purchase some token, and then I can participate depending on how much a token I've purchased. I can now include or lock that token into the protocol. And in exchange for that, the protocol will pay me some rewards for proposing blocks.
Interesting.
So semantics are very similar, But now, instead of doing all of this really expensive work in terms of energy consumption, in terms of hardware, now I'm just putting up the capital, right? Instead
Gotcha.
of, liquid capital or liquidity in terms of token.
That makes a ton of sense. So if I do put up capital, does that then filter out the bad actors?
So it's proof of stake's a little bit more complicated. In most proof of stake networks, you have to gain 67%. Then 67% of all token in the system, right?
Wow.
In order to take control of the network, right? So these high valued proof of stake networks are still they're very hard to take control of the network because Casper network, for example, our circulating supply is 4.1 billion. The total amount staked is, today it's 7.5 billion. So you would have to get actually more token that is available in circulating supply to attack the network, right? So the network really has fantastic security. And so some of the same principles do apply. It filters out bad actors because the protocol can actually reject transactions that, do things like try to spend the same token twice, or they have the wrong, they've gone and processed a transaction that the rest of the network doesn't agree upon. So the network does have a way to validate everything that is being proposed on the network in a very similar manner as Bitcoin and Ethereum do.
This is why people think Satoshi could be conspiracy or aliens, or it's so complex. It's checks and balances. It's what the American government was supposed to be, with checks and balances, but it's distributed and decentralized. This is amazing. Where do you think all this came from? Just incredibly smart people?
Yeah, Vitalik kind of blazed a way for all of us, right, around smart contract computation when he invented Ethereum and the EVM. And then I think the space has, taken his initial ideas and really iterated on them, right, and have built. I feel like Ethereum is a first generation technology, right, but it's by and far the leader in the space. It's got fantastic adoption, a wonderful community. But yeah, I think that, really smart people have come together and, when Satoshi Nakamoto invented crypto economics, everybody's light bulb kind of went off and they were inspired by the Bitcoin white paper. And then with, Vitalik coming up with Ethereum and adding computation to the blockchain, even though it was initially a very naive is not the right word, but, a very preliminary or proof of concept, it has allowed the space to generate all of this tremendous value and allowed for all this innovation to kind of flourish, right, in the space. So for that, we will always be standing on his shoulders, right, as the giant that he is. We wouldn't have been able to do this without him.
Can you explain the difference between layer 2 and layer 1? So layer 1 for everybody, she mentioned Ethereum, but now you have Polygon and some other things that are layer 2. Explain that, because layer 2 is so much cheaper. There's bridges that you can, transfer between. Give us you're amazing. Has anyone told you you're amazing at breaking down very complex things into?
Thank you.
Wow.
Thank you. So the way I think about layer 2, you can liken it to our current banking system, right? So our current banking system, layer 1 is the central banks and SWIFT. Layer 2 is like PayPal, right? It's like PayPal. It's like the credit card processing systems, right? They don't actually work with the central banks, right? So you can think of layer 1 like this very slow, hardened process, right? And layer 2 will occasionally connect to layer 1. But let's say on layer 2, you may process 1,000 transactions and then you batch them all up and you put the result of all those 1,000 transactions on the layer 1. And so the term for this is called settlement on chain, right? So the layer 2
settlement
on chain. So you process all of this stuff and that, just kind of imagine it like I've done all this work. I've got all my transactions I processed during the day. And at the end of the day, I roll everything up and I go to the bank and I deposit it.
Yes.
Right. So from my accounting perspective, I may not be accounting for all the transactions that happened in that day, but finally the master record I look at is what gets deposited in my bank account.
Gotcha.
Layer 2 is very similar to that. They do what we call optimistic roll up. So they optimistically believe that most of the transactions are going to clear and then they settle all at once. So they keep some record of the transactions off of the main blockchain. They do it locally. And because they do it locally, they can do it much more cheaply. And then they settle everything with a one-time cost on the underlying blockchain.
Wow. Do you know how often, I mean, I love the analogy of going to your bank at the end of the day. Is that legit when it happens daily, or does it happen every X amount of transactions, or is it kind of random?
It varies. It depends on how the layer two is implemented, right?
Wow.
It could be, it could be configurable by the smart contract author or by the layer two. They say, yes, we want to settle every hour, every 2 hours. It just really depends
Yeah.
in terms of how much optimistic processing they need to do
Yeah.
and how impacted the underlying blockchain is. But yeah, I mean, it's basically, that's the idea of layer two.
Perfect. So here's a thought. You've spoken very deeply, but you've broken it down where I could at least hang with you. But I've done hundreds and hundreds of hours of research. What about for the person who says, "Oh my gosh, this," look, there's stuff out there saying Web3 is a scam, crypto's not for real. And the way, once you know it, you're like, where are these people even coming from? But why do people just accept the headlines? Is it because we don't want to think, or is it what's your take?
So I came from the dawn of web 1, right? So I was working in technology at the dawn of the internet. And
Wow.
I remember very clearly when people were afraid to put their credit cards into any website.
Oh yeah.
They would be afraid of phishing scams. I remember instant message channels where it was like scary. It still is for some demographic, right? You don't want your kids on some random chat, right?
Sure.
But I feel that this is a set of growing pains, right? Like we're still very, very early in the space. And I see a lot of similarities between the dawn of the internet, which was, 22, 23 years ago, right? And what I see at the dawn of crypto, right? We're at
Mhm.
the still very, very early. It's hard to use wallets. It's hard to store your crypto. People lose private keys all the time, right? So people are getting scammed and there's phishing attacks and, so we have real UX problems within the crypto space. But I believe that there is technology that's being incubated and built today that will enable end users to
Mhm.
safely transact and interact with crypto, and get the benefits from crypto, right? And I mean, that's one of the things that Casper Labs is really looking to do. Like we're talking about ourselves and the Casper network as being a scaling solution.
Mm.
And most people in the crypto space, when they think of scaling, they think of speed. But I actually think of scaling as much, much more broad than that. I think of like scaling out adoption, scaling
Yes.
accessibility, right? And we're doing that by actually working with companies that are household names to get them to use blockchain, namely public blockchain, so that the benefits of this technology, this wonderful technology, can be made available to everybody through the interfaces that we interact with every day, right? So
Yes.
if we're working with life insurance agencies, we're working with banks, and these are household names, right? We're working with other companies to build new and exciting marketplaces. And this will provide greater access for everybody to interact with blockchain technology and really reap the benefits without necessarily needing to work with the protocol, because it's a protocol. Like HTTP is also a protocol, but nobody has to worry about HTTP, right? It
Yes.
sits in the background where it should be, right? We
Yes.
just see the benefits of it.
Yeah, that's a great analogy. I heard a speaker mention that once. Like at the beginning of the internet, we literally had to type out HTTP,
Hmm.
um, and now you just enter in your browser the name and it just knows it. So I like
Yep.
how you're saying that. You're basically saying that right now it's a lot of early adopters. There's going to be some static. There's going to be some sideways energy. There's going to be some bad actors. But also, let's face it, early adopters, there might be pain, but there's also rewards
Hmm.
of being an early adopter. What are some of the rewards that you're seeing from companies and individuals that are saying, "You know what? I get it that it's imperfect, but I'm at least gonna jump into the conversation."
So definitely for the rewards, there's great opportunities for new entrepreneurial energy to come into the space.
Mm,
Seen a tremendous amount of new entrepreneurs grow up, and these are young entrepreneurs, right? So we're
yeah,
talking about the 18, 19, 20, 22 year olds, right,
mm,
that are coming up with great ideas, and they're able to pilot these ideas and get funding from all these layer one protocols, which is amazing. I think this is just so spectacular. We're also seeing opportunities for these young folks in terms of development, right? So they can actually leapfrog into a brand new space that is like the number one growing space right now, right? So in terms of employment opportunities, if you're ready to dive into blockchain, it's a great way to be future proof, right?
wow.
I believe that blockchain is here to stay. And it is, like, right now on LinkedIn, the number one, right, searched for skill is blockchain technology. And
Mm,
you don't need to necessarily be a developer. You can do a lot of work in Web3. Like, all of the disciplines are available to you in Web3 if you're interested in learning about how the technology works, how the business models work,
yes.
and how space is rapidly evolving. There's tremendous opportunity to kind of join the next wave and be on the bleeding edge of this tech.
Digital designers, chief metaverse officers. I mean, it is mind blowing how blockchain is just opening up all these new opportunities. Talk to me a little bit more about Casper because you've given so much value. Like, talk to us about why we should get involved. What would we get involved for with Casper?
So Casper is doing something very different than all of the other blockchain protocols out there, right? We are specifically focused on enterprise adoption, and we're specifically focused on scaling out adoption of blockchain beyond the Web3 community, right? And what makes this really, really interesting is we want to see enterprises use public blockchain infrastructure. And the product that we've built will enable them to do that, right?
Mm,
Which, and it's a lot of real technical details, but in a nutshell, enterprises are beholden to regulatory bodies, they're beholden to their investors and their customers. And so they need some centralized control over their on chain code, right? And so we don't take a really hard stance on the immutability of your contract, say from today moving forward, right? So we believe the future is unwritten, but the history should be immutable. So we take a
mm.
very middle ground approach, whereas many of the other blockchain protocols take a really hard stance on immutability. And so we kind of softened our stance on that, saying you can upgrade your contracts and you can centrally control your contracts because we believe that enterprises are beholden to do so.
Ooh, I like this. I've never heard this before. So you're basically saying that the diehard blockchains, traditional, they're basically saying you can't change the past or the future. You're saying you can't change the past, but you can update the future.
You can actually update what's happening from today moving forward. Correct. So if I have a new regulatory requirement and I need to comply, I can do that if I'm using Casper, right? If you're using other protocols, it's very, very challenging because you basically have to put a bomb in everything you've built in terms of your software, right? And you have to start over with a new version. So Casper really operates, the logic on chain operates very similar to regular software. There's
Mm,
an option to do what the other blockchains do too. It basically means I just will never change my code. So, contract authors can also take that option because we recognize there's a need to do that for some protocols. There needs to be strong trust, right? That it's never going to change. But we believe that for the overwhelming majority of software that exists in the world today, for enterprises, they need to have some central control because they are beholden to regulatory bodies, and they're responsible to them. So we need to fill that void, and I think in so doing, they will be more likely to adopt this highly permissionless and trusted protocol because they also need that as well in order to gain consumer confidence.
would it still show a record of what they changed, or does it complete?
Yes.
Okay, so that's interesting.
Well, the logic will write something different from this point forward, right?
Mm,
So in the
but if you could,
past,
oh
the
yeah,
logic has never changed, right? It's not like you can just go through and do a database update and update all your historical records, right? And that's what you see happening all the time. If you want to cover something up or there's some malfeasance, they will go back into the database and rewrite everything. You can't do that on Casper. There's no
that's
way
so
to do that. But what you can say is we have a new set of rules starting from today. And now moving forward, these new rules will take effect and we will start writing records in a different way. That you can do. You
That's
just
so
can't go
good.
back and change the history.
All right, last couple questions. You describe that as here's our take, here's our approach. Is there I love paradigms and frameworks. Is there a type of stance that every blockchain has? Like you said we're the middle of the road. The other one is what? You can change anything any day in the past. The other ones you can never change it. So that's kind of the extremes.
Yeah, so the two extremes are you can never change anything, right? And that's one of the strong stances that Ethereum takes, right? They had the one change, which is the DAO
Fork,
hard
right?
fork.
Yeah.
Ethereum Classic didn't even accept the DAO hard fork, right? So that's the strong stance that they take. And it's preferable to be that way, right? Like you're not going to have confidence in a blockchain that is able to just go willy-nilly changing stuff, right? Then the trust model breaks down. The other flip side is these private chains like on Hyperledger and such that aren't even really a blockchain, right? You can do just about anything you want. It's like the Wild West there, right? So the trust guarantees on those systems are very, very low because they're centrally controlled, wholly controlled by
Interesting.
a single entity, right?
Okay. I love it. And explain, I've heard Hyperledger before. Give us the quick rundown on Hyperledger.
Hyperledger is a technology that is only a private blockchain technology, right? So it is not designed. It has no design in its system that allows for permissionless deployment, right? You can never take a Hyperledger system and make it permissionless, right? It will always be centrally controlled. It doesn't have like a real formal consensus algorithm. It kind of has a consensus algorithm. So the nodes will agree on some set of transactions, but it isn't battle tested because it's not running in the permissionless in the public domain, right? So it's a very loose sense of agreement around the nodes, right? So they're like, oh, I see this. You guys all just pick up what I see, right? It's kind of like that.
You ever hear Andreas Antopoulos's example of Hyperledger being the bubble boy that can get an illness or virus, but the other extreme is the sewer rat, which is just,
getting
it can
pounded.
handle anything. Yeah.
That's right. That's right. Yep. That's exactly right. And that's a great differentiator between, Hyperledger and these public protocols.
This has got me so excited. I'll tell you what. And I love how your name is Medha. Now I know it's spelled different than META, but do you get any teasing about that at all?
I don't get teasing, but I have been told that I need to start a blog. So I'll be starting a blog here pretty soon, metaverse.blog, which I thought was really cute because it'll be an opportunity to talk broadly about what it is I'm doing and, my thoughts on the space. So I'll be launching that blog here in the next few months with a
Make
steady
sure you
drip of
buy the
content.
domain name.
I did grab the domain name. Yes.
Good, because that's important. You were fantastic. Do you have any, I'm a publisher, so I love books, but do you have any books out yet, or is that something you'll do in the future? What are you thinking?
Perhaps in the future I'll do something. I don't have any books out yet because I'm, fully focused on building the business and, supporting the Casper protocol right now. But definitely something that is on the table in the future. I'll start with the blog first.
Yeah, well, we'll have to at least weave this into. I'm writing a book called Blockchain Life, and wow, you broke down the definitions really good and simple, which is fantastic. So what else can I do to support you, your company? Can we follow you? Is there what do you think?
You can absolutely follow us. I'm on Twitter at @mparlikar and Casper Labs. We're on Twitter as well, and the Casper Network. And our website is casperlabs.io and casper.network. So absolutely get involved, follow us, and hopefully someday soon, we'll have products on the blockchain that you guys can start interacting with. So we've got a few that are coming out soon, right? We have wise.art for an NFT marketplace, Medha Cask, where you can buy rare whiskey casks on auction, which is really cool. So if you love whiskey, they'll be going live soon on Casper. And then, of course, we've got a patent marketplace as well for those of you that are looking to purchase patents. And more really cool enterprise applications that'll be coming to Casper Network.
give me 60 seconds on .io because I love .io. I bought a ton. In fact, if you got 5 minutes after, I'm going to be really quick. But last thing, why is .io hot for a lot of Web3 names?
Because we see blockchain as like input output, right? So that's why it makes a lot of sense, because you're focusing on a protocol specifically, or
Yes.
protocol related work, right? So you put information on the blockchain, you get a confirmation out of the blockchain. So it's that kind of workflow, right? So the .io makes a lot of sense in that
Ooh, that's good.
aspect.
That's good.
Yeah, yeah.
Well, thank you so much for being here today. Again, we'll stop the recording, and I just want 2 more minutes with you. But thank you so
Sure.
much.